And my name is Alexa Brea.
And today we're going to be talking about our experience at the Wilkes Robotics Summer Program.
First day at Wilkes, we successfully integrated an AI-driven autonomous system into our robots, which allow them to navigate independently. For example, when it sees a stop sign, it will automatically stop.
For our next project, we did a robot line tracking sensor using a photocell. So to build this project, we used a photocell, breadboard, and an LED. So how does this project work? So basically, when the photocell is covered, the light of the LED will decrease significantly, letting us know that there's an obstacle. And we could implement this into a robot to basically do the same thing for the line tracking. That's just basically like the grayscale.
For AI plant needs water, we built custom sensor circuit to track soil conditions, which led AI to process data instantly telling us if the plant needs water, if the plant has too much water, or is perfectly leveled.
And as Ariel said, the more water it has, the more bright the LED will be. So then we step into handcrafted sensors. So this is the same principles as the photocell, but instead of photocell, we replace it with buttons. So how does this work? So we're simulating that our robot runs into an obstacle, and based on which buttons are pressed, the robot will make a decision. So if the center and the left are pressed, the robot will basically decide to make a sharp right turn to get away from the obstacle.
While building this, we learned that the smallest mistake or detail can affect how a robot acts. This is why engineers have to test their project over and over again to see if they can get it right.
And when you're coding, this is really important because you can be shaking the software, and it could not be that, it could be also the hardware. So then we used the Pico robot that we built previously, and we did a maze project. Well, we basically programmed the robot to escape the maze by itself. How does it work? So the robot uses an ultrasonic sensor where it looks 3 directions, front, left, and right. So if the robot runs into that wall, it's going to look left and right. And since the right distance is larger than the left distance, it will go to the right.
Line following, we built and programmed a Pico 4WD robot to follow the tape track, which mimics the real-world logic like companies like Amazon that uses transport to they transport packages across their warehouses floors.
And we have a little example of that we're going to show you. Sorry for the delay. As you can see, the robot is using the grayscale to follow the line properly. And like she said, a lot of companies uses it to make the robot able of going through the company without having to run into people. Then we step into physical control circuitry work, utilizing basic principles of push buttons and delays. What are push buttons? So push buttons are basically buttons that the programmers can use to stop the machine, make it go, or even change like the way it's going. We also got to make our own project, and where we decided to make an automatic closet. So what is my project? So it's a spinning closet that has AI implemented into it, and you can tell it what you want to wear, what don't you want to wear, and even the weather. And it will choose you an outfit based on the information you gave to it.
We also studied how human and machines communicate. We also wanted to see how to design simple, easy-to-use interfaces so human operators can control automated machines.
Then we step into Linux, which is a little bit more complex. It's a way of programming that most engineers use to like control the drone. We also use a simulator called Q-ground control, in where we can make real-life missions and see how the drone is moving, and like we can see the robot. Sorry, I get confused. So we can see how the drone is going from point A to point B, and how much time it will take, and possible problems that it can go through.
We also use MATLAB to learn how to code, and we also made simple scripts on how to solve problems, and made visual charts to learn how the program works.
Then, a little bit more of drones and sensors, we gain a deeper understanding of how programmers can put instructions into the computer and pass it into the drone. So, and it's pretty amazing how the drone can go by itself without the needing of controlling it with a phone or a controller.
We also use reverse engineering to fix broken parts and use different tools like the caliper to take exact measurements. And with Corey at PSA, we also make accurate drawings to create a new copy of the product.
Then we step into PLC, ladder logic, and digital logic. We learn about dead logic, which is basically a way of programming, like I said before, the machines where you're telling it how to react of the instruction you're giving it by the push buttons, and how to react to the delays.
We also, for reverse engineering, we also took apart devices to see how they work inside, checking how the parts helped us find problems, fix them, and improve designs.
Then we got to disassemble a drone and put it back together. By doing this, we got to see how each element works together safely, and why they put it in certain place, and how different elements like carbon fiber can make it fly more smoothly and make it lighter.
The lesson that we learned is that being in this program, we really gained good engineering skills, and also learned that patience and constant testing is really important in fixing code and building circuits.
We also learned that this is not only just engineering, it's about patience and all the work you put into it. And like my teacher said, it's just like if you take a big bite of an apple and you can't handle it. So you have to break the problem apart into smaller pieces so you get to understand it and you know what you're doing.
And the overall summary throughout this is that using sensors, self-driving systems, drones, and MATLAB really gave us the skills that we need for the future if we want to work in technology or automation. And thank you for listening to our presentation.
All right, thank you guys so much.